Hi there, welcome to the content highlights for chapter 6.2 and 6.3. In this section, we're going to look at some algebra stuff along with some word problems. Let's start with the basics. Solve for x, and in this case, we're required to do some order of operations, so it's a little bit more of an advanced problem of the basics. Start by distributing the negative sign in front of your parentheses. So we have 9x minus 5x minus 3 equals 17. Let's combine like terms before we start moving things around. 9x minus 5x gives us 4x minus 3 equals 17. Now we can start moving things over. Since we have all of our x's already on one side, I'm going to move our constant to the other side, which gives us 4x equals 20. Divide both sides by 4. And that leaves us with x equal to 5. To make sure we've done this correctly, we can go ahead and plug back in to check our work. So to check, let's see if when we plug in x equals 5, if we get the same answer. 9 times 5 minus 5 times 5 plus 3. Does that actually give us 17? Parentheses first. 5 times 5 is 25 plus 3 gives us 28. 9 times 5 is 45. What does 45 minus 28 give us? That in fact gives us 17, which means that we have done this correctly, and our answer, x equals 5, is in fact correct. Next up, let's look at another basic, this time dealing with some fractions. Now, anytime you're dealing with fractions, one technique you can use, aside from finding a common denominator between everything, would be to multiply through by the least common denominator. Now, this is probably one of the simpler ways of doing it, but it requires you to always check your work, just like we did before. The common denominator between 5 and 6 is going to be 30, so what I'm going to do here is multiply each term by 30. Now, what that means for us, before you try and distribute these, please, please, please cancel out any common factors. 5 goes into 30 6 times, which means that this whole first piece is 6 times x minus 5. Negative 1 times 30, just minus 30, nothing to reduce there. And then same thing, reduce 6 into 30 goes 5 times, which means to the right of the equal sign here we have 5 times x minus 14. From this we can see that we've turned this into a simple equation. Distribute. 6 times x is 6x minus 30 minus 30 equals 5x. Then we have 2 times 14, I'm sorry, 5 times negative 14 gives us minus 70. Combine like terms on the left, we have 6x minus 60 equals 5x minus 70. And you can move all of your constants to one side and all of your variables to the other side. What I'm going to do is subtract 5x on both sides and add 60 to both sides. So then we can see here the 5x's cancel, the 60's cancel, and that gives us x equals negative 10. Now, to make sure we've done this correctly, let's go ahead and check our work. If we plug this in, we get negative 10 minus 5 divided by 5 minus 1. And we have to see, does that equal to negative 10 minus 14 over 6? Negative 10 minus 5 is negative 15 over 5. Still checking, does that equal negative 10 minus 14, negative 24 over 6? Okay, negative 15 over 5 is negative 3 minus 1 gives us negative 4. Does that equal negative 24 over 6, which is also negative 4? So we can see that we've done this correctly. Now, the last of the basics I want to show you is dealing with decimals. We can use that same technique like we did here of multiplying every single term by something in order to get rid of the decimals. This makes things a lot more convenient if you're doing this, especially without a calculator. It makes the numbers much more manageable. Now, we notice here that everything only has a tenths place to it. And when I say everything, I mean anything with a decimal is only to the tenths place. That's what dictates what you're going to multiply. It'll always be a multiple of 10. Or, I'm sorry, not a multiple of 10, but a power of 10. So if we have one decimal place, we're going to multiply everything by 10. If we had two decimal places, we're going to multiply by 100, three decimal places by 1,000, and so on and so forth. So here, every single term that has a decimal only has a tenths place rather, so we're going to multiply each of these by 10. What this does is allow us to move our decimal over. 10 times 0.3 is 3, so that is 3x plus 3 times 20 equals 2 times x plus 40. Simplify what we can. 3x plus 60 equals 2x plus 80. I'm going to move my constant terms over and then move my variables over. So that gives me x equals to 20. Just like we did before, let's go ahead and check our work. When we plug in, we have 0.3 times 20 plus 0.3 times 20 equals 0.2 times 20 plus 40. If we simplify, 0.3 times 20 is 6 plus another 6. Does that equal 0.2 times 60, which is 12? 12 is in fact equal to 12, so we know that we have in fact done this correctly. Moving into the word problems, bear in mind that most of these types of questions can be set up very simply into basic algebra problems. This is also going to be something we're going to stick to following once we get into Chapter 8. And it's kind of nice because if you build that foundation here, Chapter 8 will be very straightforward in the future. A new car worth $22,000 is depreciating in value by $1,800 per year. After how many years will the car's value be $5,800? Well, we know the original cost of the car is $22,000 minus $1,800 per year means, well, we don't know how many years, so I'm going to call that x. And that is going to be set equal to the new price. So we have our original minus the amount depreciated equal to the new price. And we notice that this is a very simple algebra problem. Subtract 22,000 on both sides, and that gives us negative 1,800x equals negative 16,200. Divide both sides by negative 1,800. And when you divide, of course, by a negative, your answer, negative divided by negative, is positive. This gives us 9 years. So how many years did it take for it to depreciate to $5,800? Takes us 9 years. And one more to take a look at here, which I find to be a little bit trickier, is when you're dealing with sales tax. Not a huge amount different, but sales tax, anything that's being taxed, whether it's an actual tax or a surcharge for something, it's always going to add to the cost. So including a 6% sales tax, the hotel charges $164.30 per night. What's the hotel's nightly cost before tax? So let's start by picking a variable here. Let's say let x equal, or whatever your favorite letter is, the nightly cost. So we want to find out how much is the actual cost per night before any taxes are added in. So that's what makes this question challenging. So normally when you go to a hotel and you get the bill, this is the part you would be seeing. Now what's the rate before the sales tax? Well, if x is the nightly cost, it would be the cost per night plus a 6% sales tax. Anytime you're dealing with a percent tax, whether it's a tax or a discount, etc., you're going to turn that into a decimal by moving it 2 places to the left. So 6% becomes 0.06. So it's the cost per night plus 6% of that cost is equal to the 164.30. X plus 0.06x is 1.06x. That's just a straight combined like terms. And then, of course, divide both sides by 1.06. And we can see that X is equal to $155 per night. So again, this is the cost before the sales tax is added, any other taxes or fees. Thanks for watching.